Okay, we're picking up where we left off with the last video. We are doing a component method problem with two vectors. So if you're just watching along from the last video, where we were, we broke each original vector up into its components, added the x's, added the y's, and came up with a value we're going to just refer to r sub x and r sub y for, let's say, the components of the resultant. We're not done, but we're getting closer. Now would be a good time to note that if we would have started with a problem, you will have some of these in the homework, that have more than two vectors, you're just going to continue this step right here. If we would have started with, also had a vector c, you would have a cx and a cy. If you had a fourth vector, vector d, you would have broken it up into a dx and a dy. So basically, no matter how many vectors you started with using component method, once you get through this step, you should just have a single r sub x and a single r sub y. Now is where we'll apply head to tail method, and I'm going to draw a rough XY coordinate system, not to scale, just a one to use, to show you graphically what these represent. So here's my XY, and let me get a solid line for the vectors themselves. Okay, very simple. This is an x component of the answer I'm seeking. So if it comes out positive, then it will point to the right. So that's going to represent my Rx. Put a little arrowhead on there, which I didn't. And using head to tail, I will put Ry on that, attached to that. So this is Rx. We'll draw Ry a little bit longer, not to scale or anything, but 24.9 is a higher magnitude than 17.6, so let's just draw it, somewhat related to size here. Let's go tail of it on the head of Rx will look something like that. That's not quite straight. Let's fix that. There we go. Put a little head arrow on there. And we'll call that Ry, which those are the magnitudes there, so I won't relist them. Now my answer I'm seeking is going to be where this one started to where this one ended, my overall resultant. That was always the goal. And I'll just call that plain old R. Okay, to get the magnitude of that now, we could just use Pythagorean theorem. We know this side and this side, so applying it, r squared will equal rx squared plus r sub y squared. We have all those numbers. We'll just take the square root of each side. Again, bear with me while I run some of these in the calculator after I write them down. And in a moment we'll have an answer, so I'm going to go ahead and square my 17.6 and the 24.9, add them together, take the square root. Make sure you remember to take that square root. So many students forget to, and then give me the answer prior to that. So I get out, rounded to one decimal place, about 30.5. Remember, this still has the same units we had all along, meters per second. I'm not quite done, but that's at least part of my answer. That is the magnitude of my answer. But if I want the full resultant, I also need the angle, which is why it's so important to draw this little diagram of your resultant components head to tail. If I don't do this, I may not realize where or what quadrant my resultant is in, and may not express that as the correct angle. So the angle that we're always putting on our resultant is the one that occurs between the resultant and where the first vector when we drew head to tail started. That would be r sub x. And at this point, none of the information leading up to this was given, so I know all three sides right now, and none of it was given information. So it doesn't really matter what you want to use, sine, cosine, or tangent. We have all the signs to find that. For no particular reason, I'm going to use tangent. So I could say to find that angle theta, that tangent theta is equal to opposite over adjacent, or in other words, r sub y over r sub x. Solving that for theta, I will get theta is equal to the inverse tangent, now I'll plug in the numbers, of 24.9 divided by, that's a bad looking 9, 24.9 divided by 17.6. Again, excuse me for a moment while I run those numbers and make sure I'm in degree mode. 24.9 divided by 17.6. I'm going to inverse tangent that number, and I get, rounded to one decimal place, 54.7 degrees. Now, for this particular example, my angle of the resultant did come out in the first quadrant. If you recall how we said were acceptable ways of naming our angle, since that's happens to be in the first quadrant, I could leave it just 54.7 degrees, but let's be a little more exact. Let's use another way I said about stressing the angle and where it is, and I'm going to say my final answer, R, is equal to 30.5 meters per second at 54.7 degrees northeast, since that's quadrant 1. Well, I really want to get the hang of stressing that is because if theta would have came out, for example, in another problem is 54.7 degrees in quadrant 2, if I didn't stress northwest there, then that's not the same thing as the terminal angle from the positive x-axis. This is the best way to do it, and there's my final answer. So just taking one more minute to kind of recap everything we just did. I know it looks like a lot, but it's really not that bad. So real quick recap going through. We wanted to add two vectors when initially we realized they did not form a 90-degree right triangle when we went head to tail right away. So when we realize that, we will split them each up into their components through SOHCAHTOA. And we will take those components and add all the x components and all the y components and call the result of this summation for each x and y just Rx and Ry for resultant component x and resultant component y. And again, one more side note was that if we had more than two vectors to add, if there was a vector c, a vector d, a vector e, and so on, you would also in this step found all their components, x and y, and just added them to this list of summing them up. At that point, once we have the Rx and Ry, we will draw a diagram to figure out where approximately this is on an XY coordinate system, a head-to-tail diagram with my two x and y components. After I draw that, I am able to draw in the resultant from where the first one started to where the last one ended. And from there, simple Pythagorean theorem and some SOHCAHTOA to find the magnitude and direction in my final answer. I hope this helps you in your homework, and we'll be going over it more as well in class.